Hi, this is Mrs. John and explaining a question about two-point source interference. So here's the question. So the diagram shows water waves as they pass through two gaps in a harbor wall. So these are the waves. These are what we call parallel wavefronts, and these lines represent the crest of the waves. And you know, in between two crests, you do have the troughs as well. Okay, now it's going through two gaps. So these are the gaps. Now when waves pass through two gaps and where the size of the gap is about the same as the wavelength of the waves, you end up with circular waves. Now these circular waves pass through each other. The passing through is called interference, and they say the wavelength is 6 meters. So I'll just mark that. So the distance from one crest to the other is 6 meters. So now there are two boats. One is at X and the other is at Y. X is the same distance from the two gaps. That means from here to X is the same as from this gap to X. So that means the distance traveled by the wave to X from this gap is the same as the distance traveled by the wave to reach X. So the path difference is 0 because the distances are the same. Now Y is mode such that it is 24 meters from one gap and it is 27 meters from the other gap. So the path difference is 27 minus 24, which is 3 meters. Okay, one wavelength is 6 meters, but the path difference for Y is 3 meters, which is half a wavelength. Now the question is, by considering nodal and antinodal lines, describe and explain the motion of the two boats. So when you have describe as well as explain, the implication is this carries more than just an achieved. Could be merit, could be excellence, depending on what's required. So let's talk about the two types of interferences. So there's what we call constructive interference, and we need to know a few things about constructive interference. The waves arrive in phase. That means a crest combines with a crest and a trough combines with a trough, and the result is very high amplitude waves. So these are high energy waves, and the path difference is either 0 wavelengths or multiples of whole wavelengths. So one wavelength, two wavelengths. So the path difference could be 0, or in this case 6 meters, 12 meters, 18 meters, multiples of 6. Okay, so all those ones result in constructive interference, and that results in what we call antinodal lines. So at X, the boat will be bobbing up and down with high amplitude. Why? Because X is equidistant from the two sources, so the path difference is 0 wavelength. So that is for the constructive interference and the antinodal lines. Now let's look at what we call destructive interference. These result in nodal lines, and that's because the waves arrive out of phase. What does that mean? This is when a crest arrives at the same time as a trough. When a crest combines with a trough, they have a cancelling effect. So these are regions of calm, and the path difference is half a wavelength or odd multiples of half wavelengths. So the boat at Y will be calm as Y is 24 meters from one source and it's 27 meters from the other source. So the path difference, 27 minus 24, is 3 meters. One wavelength is 6 meters. So half wavelength is 3 meters. So that's your answer. I hope you made sense.